and I'm going to share my screen. We're going to get started with today's class. There you go. And today we have two really interesting topics, really important, conceptually really important topics. As you guys know, and we've said this a couple of times, we try to focus on concepts. We want you to be able to, at some point, change the programming language you're using, you know, transition to Ruby, JavaScript, whatever, and still everything that you learn here should be still useful. Oh, by the way, this class too. My bad. And both of the concepts we are going to be talking today are related to that. You know, they will be useful throughout your entire life. These are not Python features. They are things you guys will be using for the rest of your lives as coders. Alex, the slides are right in the platform next to the join class link. So if you go to the platform, let me see if I have it open right here. Right here, you see the slides. So functions. I'm just gonna get started. As usual, the ones that have joined as panelists, you guys know you can interrupt me at any moment. Those that are asking questions through text, keep doing it. Again, I sent an email today. I said it's really valuable to get questions. You know, it's what makes these class more interesting. You know, because for us to be just moving through the entire code, you know, or slides, just doing something. So someone raised, Adrian, you raise your hand. You want to be a panelist? I wasn't noticing it. No problem. All right, so let's keep moving forward with functions. Today's topic is functions. So a function is basically a block of code that has a name, and it helps us in a couple of different scenarios. It will let us reuse code, abstract functionality, all you guys can see here. I'm going to show you a couple of examples how functions work, and then we're going to go back again to this slide to like see how they're helping us achieve these small pointers. So let's start with an example. And the example here is we have 3 different temperatures: New York City, San Francisco, and London. We have them expressed in Fahrenheit, right? Fahrenheit degrees. And what we want to do is print them we want to print them both in Fahrenheit, in this line, and also in Celsius. So I can just copy this, move it here, and run it. So you guys see that we have temperature, New York City, Fahrenheit, Celsius, and Fahrenheit, Celsius. The issue we have with this code is that we are repeating some of this code is repeated, and usually you guys will find repeated code which at some extent is fine, unless what you're repeating is business logic. All right. By business logic, I don't mean money, but I'm talking about a certain type of rule, right? That the system needs to follow. How to convert from Fahrenheit to Celsius is one rule. You know, it's something that we, as the creators of the program, have to specifically put. So here, for example, we have the temperature in New York City this is repeated, but it's not as bad, you know. But this part right here, repeating the business logic is really bad because of a number of reasons, right? What happens if we have a really tiny bug, you know, like the one here? Did you guys notice this one? We might have a really tiny bug by just copying and pasting, and we wouldn't notice that, you know. So that's something that's dangerous. It's also bad if we ever need to change something. You know, if we're gonna have and say, hey, remember when we were doing this thing and sending it to the users, sending the welcome email to the users that join after, I don't know, 3 hours. From now on is 2.5 hours instead of 3 hours. We have to go through our entire code, changing every new occurrence, of that. In this case, it's hard that we're going to change the way we calculate from Fahrenheit to Celsius, because we will usually use the same formula. But let's say we are going to change this to 32.2, sorry, and we have to go and change it in every place where this function, where this piece of code is applied. So this is a really good candidate for a function. And here, those of you that have like the mathematical knowledge of functions, you guys should transfer it also. It's like you have a function f of x, that receives a parameter, and it's going to perform a certain action and gives you something else. So this is a really good candidate for a function, and not as a mathematical function, but as a programming function that we're going to see how it works in a second. So what I'm going to do is, before showing you how to write them, how to pass parameters, return things from functions, what I'm going to show you is how we apply them, so you see them in action. You see how we use them. It's the same code when I'm repeating the first business logic over and over again, minus 32, the result of that times 5 divided by 9, the same thing 3 times. Instead of repeating the same business logic, I'm going to apply the same function. And this is how the code looks like. Instead of, again, doing the operation by hand, I am relying on an external function, the one that I created, that it's 2 Celsius, that it's receiving the Fahrenheit temperature, and it's transforming it back to Celsius for us to use. So the end result should be the same. The end result is going to be the same. I will print the same temperature, the same temperature in Celsius, but the way I computed that temperature is different. I'm relying on a function, and a function will have all these benefits, as I will be showing it to you in a second. What we can see right now from these benefits, it's like we were repeating code, repeating minus 32, multiply 5 divided by 9, the same thing 3 times. Now what we're doing is we're invoking the same function 3 times. If we ever need to change something, again, we got to move from 32 to 32.1, for example. That's going to change inside a function, and we will have to change it just once, and the function, of course, will take care of the rest. If we are the ones writing this code, the only thing we see is we are invoking the 2 Celsius function. This is the only thing that we see. There's no more information for us, and that's a good thing. We as programmers, we don't want to have too many things in our brain, because that means more complexity. That means more brain load. We want to decrease it. We want to just focus on the problem we're trying to solve right now. And the problem, what we want to solve right now, is printing the temperature in Fahrenheit and Celsius. How to compute Fahrenheit to Celsius? I don't know. I can leave it to the function. The function can take care of that, and that's fine for me. So we are reusing code, and we're abstracting functionality, abstracting from the programmer, from me. I'm the programmer, I'm abstracted. I don't know what's going on inside here, and that's fine. That's actually something that I want to preserve. So, by the way, let me go really quickly about the other pointers here. Divide work, it's also good to divide work, because I could start writing this code, and I could hand the task of writing these functions to someone else. It's like, hey, I'm going to take care of printing this report that is going to show all the temperatures we have gathered. And in the meantime, can you go and write this function? And then we're going to put everything together. And I will just, while I'm writing my code, I will expect to have a function 2 Celsius that is going to receive a Fahrenheit temperature, is going to return it, transform to Celsius. So you will take care of that. I will take care of this reporting. And when we have everything together, we can merge it, and everything is going to be done. you know, and we are dividing the work. That's a good thing about functions. Encapsulation, it means it's something similar to what we were saying of abstracting functionality. It's like everything's going to be encapsulated in the same unit of functionality. You know, it's just the function is a unit of functionality. And the code is going to be easier to test. That will allow us to prevent these sort of simple or tiny, not simple, but tiny bugs that are really hard to spot. You know, we will, if we have a function to Celsius that receives any Fahrenheit temperature and returns the temperature transformed to Celsius, we can just test it with a couple of values we know. We can just go Google how much is, I don't know, 75 in Fahrenheit transformed to Celsius. It's 23. And I can try running my function, just the function, alone, isolated, separated. And if that's the result, then the function is working correctly. If I'm not using the function, if I'm manually putting the values here, I will have to go and test each one of these cases, and it's going to be a nightmare. Right? So that's the final pointer right here. That's why a function is so important, so good. 1 second, guys. All right, so let's see how to write a function. This is really important. Here, you're hopefully understanding how to use them. Barely, we're gonna, of course, give you more details on how to use the functions, and at least why they're so important. But let's now see how we write a function, how we can create our own functions. And again, the idea will be to abstract some functionality, to group it. You know, instead of repeating, we want to group some functionality in one function. So the function anatomy is this one as follows. It's going to have a def keyword. Every function in the Python programming language will have will start with def, from define, definition, I don't know, to be honest, but along those lines. The name of the function should have a meaningful name. What's the function doing? Usually we're going to say that a function will start with a verb. You know, it's going to say, do this, you know. There are, of course, exceptions, but usually we're going to say that the action that it's going to perform, you know, in an imperative way. Change name. We had a bad example, maybe to Celsius, but you guys understand what's going on. But it's important, aside from the rule that you want to follow, that the name is meaningful. As long as you understand what's going on, that's a good thing. Then we're going to receive 1, 0, or more parameters, right? When we have here parameter, we can have, again, 0, 1, many. It's pretty flexible depending on our function, what our function expects. And we're going to see, of course, more in detail. And finally, we're going to return a value, the result. A function is just that, is some functionality we're grouping all in just one block of code, and we're giving that block of code a name. And so we can then rely on that block of code many times just by name. So to Celsius, we can invoke to Celsius as many times as we want. Send email to user, and the parameter that receives is the user, and it's sending an email over and over and over again, and that's the result. I don't know, the average, you know, compute the average of these numbers, and we pass many numbers. And it's going to receive many numbers, and it's going to compute the average, and it's going to return the average. You know, so that's where functions, for those of you that have some math background and you remember traditional simple functions from high school, like fx returns something, it's really important that a function returns. All right, a function has a result. A function has a result. We're going to see everything in more detail, so don't worry too much about it. How do we invoke a function? We were doing it right here, but to see it in more detail, we're going to invoke the function by the name that we gave. So that's why it's so important to give a meaningful name. And we're going to pass the parameters. The function invoke you will notice, because it's the name of the function, you're going to start with parentheses. Oh, this doesn't belong here. We're going to start with parentheses. So we're going to have opening parentheses, all the parameters you want to pass, and the closing parentheses. And you guys can match like the parameters that you're actually passing when you invoke the function. In this case, I'm saying hello with the name Jason, with the way this function was defined. It was same name, parentheses, and the name that it's expecting to receive. Really, really important, the difference here. We're defining a new function here. This is the way we write it, generically. When we write the function, we don't know yet how that function is going to be used. We just write it generically. And then we have the time when we actually invoke and use the function. So we're going to say hello to Jason, and we're going to keep that result in a variable. So that's important too. This function will be performing some operation and returning a result. That result is going to be stored in the variable result. And we're finally going to print that value. In this case, we're printing it, but aside from printing, I shouldn't have said we are going to print it. It's not going to be always printed. We're going to use this value in our code. In this case, for the example, I'm printing it, but you guys will be using it, whatever value you got. We have this user, and we're gonna get the age of the user with a function. Given the user's date of birth, we're gonna get the age, and from the age, we're gonna use it. For example, we can restrict access. We're gonna enable some sort of special feature. I don't know, but we're gonna use that value that the function computed for us. Make sense? Questions? We're gonna go more detail in all these, regarding all these concepts in a second. So again, I was showing you the anatomy of the function in general, generically, with probably one of the simplest examples. Keep in mind here three really important things: is the name that you give to your function, the parameters you're expecting, and the value returned. Again, we're gonna go in more detail about these things. So back to the two Celsius functions. How is this function defined so we can actually apply it right here? If I put these here, right, I try to use, let me separate these so it's clear where the different cities are being applied. If I try to do this, it's going to fail because 2 Celsius is not declared. I have to write the function. I have to write it, or I have to somehow make it available for my current code. Sometimes I can import them from other modules. We're going to see more about that later. But more importantly, I have to somehow make it available. In this case, what I'm going to do, of course, is define it. I'm going to write it by myself. And the way to write the 2 Celsius function is really simple. We can actually go back to the piece of code that had it repeated and see how it was applied, right? And just from there, take the more generic way of writing the same function. So here, what is happening is that you can do something for one particular example. I give you the temperature 75, and I can ask you, can you convert 75 Fahrenheit to Celsius? And you're going to say, yes, I can. You're going to put 75, right here. You're going to, given the particular result or value, sorry, given the particular value that you have, 75, transform this to Celsius. You're going to do 75 minus 32 times 5 divided by 9. And I'm going to say, can you do the same thing? Can you, from another temperature they're going to give you, can you turn it to Celsius? And the temperature is, for example, 61. You're going to say, yes, of course, I can do that too. And I can do the same thing for 59. So what we see here is that we have the procedure, the function is pretty much always the same, but what changes is the original temperature we have in Fahrenheit. So we have 75 in Fahrenheit, we're going to have a given result in Celsius. This is what is going to make our function. We're going to change this value. We're going to make this value variable. We're going to make this value generic. And we're going to write our function saying def to Celsius. Again, the name, we can give any name we want as long as it's meaningful. And here we're going to say, I don't know right now what values I'm going to receive. So I'm going to make this generic. And I'm going to say, assume that I'm receiving a temperature in Fahrenheit. You know, I'm actually, I think I have the function written right here. There you go. So I'm going to get the temperature in Fahrenheit. And it doesn't matter what the temperature is in Fahrenheit. I don't know the number right now. I don't know the number right now. But I can just replace this thing here, well, here. And this function is now generic and dynamic for any value that I pass. I pass 75. 75 is going to be received here. It's going to be replaced. And now this function is, of course, going to be computed as it's supposed to be. So here what's going on is that 2 Celsius is defined for every value. It's a variable value. And if we go back to our simple math class, and you guys remember f of x, you know, being equals to y, whatever, it's exactly the same thing. We had a function that was receiving a variable, you know, a variable value, in this case, 10 Fahrenheit. So we're defining our function. We have a couple of particular cases, like examples of real applications. This was invoked with, this was invoked with 75. This one was invoked with 61. This was invoked with 59. We have particular examples in our mind. And from there, we construct a more general example that will be useful for every value. You know, it doesn't matter what you pass, this is always going to work. So if I run it now, you see pretty much the same result as before, but now we're using the function. So we have a couple of questions. So Shoy is asking if by the way, guys, let me answer the questions in open language so everyone can hear them, because maybe someone is not like paying attention. So Shoy is asking, could this 2 Celsius function need to come before the print statement? It depends where. So if we I'm writing here, typing in a new piece of code right here. Right here. So I'm going to do, I'm gonna go over that again in a second. 1 second, I'm gonna go over how temp Fahrenheit is matched. So if I do something like, let's say that I want to convert the temperature in Fahrenheit 80, I'm gonna turn it into Celsius. I don't know how much is that. So what I'm gonna do is I'm going to apply the 2 Celsius function to the value 80. All right, I'm gonna pass 80 as the Fahrenheit temperature. And this is going to return to me, 80 in Celsius. So I'm gonna call this Celsius 80, just any name that you guys want for the variable. Again, this is a variable. We can create any name that we want. And now I have the result of that function in this variable. If I want to print it, and I assume this is why you were asking this, right? What I'm going to print is the Celsius temperature transformed from the 80 in Fahrenheit. This is 80 from Fahrenheit. I'm just giving an awful variable name, but I wanted to make it really explicit. So now to your question, does the function come before the print? Yes, of course, because what you want to print is the result of this function. So you need the function to be applied first. You want to generate that value. And I want you guys to extend this thing and this notion of functions to your everyday life. It's not that we are making a meaningless function to Celsius. I want you to start thinking about it. You know, it's like what you will see things that are repeated all the time, and you can apply them. You know, you go to a website and you log in. That involves a function. You know, it's some processing that it's done all the time, and it's logging. It's logging you with your email and your password. It's logging me with my email and my password. And there, the logging function, if we could say that they have, has an email and a password. You know, that's the variable data. And they are applying the same function all the time. They're receiving email and password from a user, and they're doing all the processing required for that email and password generic to log that user in. You know, so it's the same. Again, a function is not this is probably a mathematical example, like transforming something with numbers. It's not the case. It's just some group, some action that you see, that you repeat it all the time, and you're just transforming it into a generic thing. I'm going to log in a user. What do I require? The user's email and the user's password. That's it, generic. I need to compute the revenue for the entire year. All right, what do you need? I need all the sales we have made. So you're going to make the function compute revenue from a year. And what do you need? The sales from that year. It doesn't matter. I mean, you can compute the revenue for 2016, 2017, 2002, whatever year you want. But the function is going to be always the same. Get all the sales, sum the total amount, you know, do the processing that you want to do generically for each one of the years. All right, so that's the important thing. Shouldn't we be doing this in Python 3? No, I don't know. We're actually working Python 2 and Python 3 interchangeably, and I said it in the first class, we're going to work with both of them depending on the case. This doesn't matter. There is no difference in Python 2 and Python 3, so that's why I have a Python 3 REPL open to show the differences, but in this case, it's the same. So can you put the def after the invocation? And I want to be real explicit here, Tim. Def is used to define the function. So here I want you guys to split your mind in two parts, you know, and kind of think about two different persons sitting, or you being two different persons at the same time. One of you is the guy that it's writing the function. It's saying, hey, I need to write a function to compute from Fahrenheit temperature to Celsius temperature. That's it. You write your function, then you're done. You're creating functions. You're writing functions. And then the other person, you know, your other half is going to be the guy that it's actually using the functions. A function only defined, in this case, doesn't have any purpose. It's just there. I run this code, I'm going to execute this code. Doesn't change anything. I mean, it's just defining a function, generic. It's like, hey, I have just designed a system that you can turn an engine in a car and it can drive if you do it. But if you never sit and turn an engine in and drive, nothing's gonna change. I've just defined a generic function. So then again, the other person, it's the same, it's you, but like the other mindset in you, the other half of you will be the one using the functions. Now that you have designed the generic way of the function works, you will be using it, you will be applying it. And that is when you will actually make a change. It will have a side effect. It will make something. Just the function there, it's not making anything. It's just void. You know, there is nothing done. So the def here will never be, and this is what I'm going back to your question, def will never be related to the function invocation. We have to draw a line here. We draw a line, a really important line, and it's from the line above, we have above here, we have the part where this function is defined. From the line below, we have the place where the function is invoked. we can never have a def here, because def is to define the function, to create it for the first time. And you're going to create a function just once. You're going to define a function just once. You're going to define the function, and then you're going to apply it over and over again. It's like learning how to do a recipe. You know, you learned your mother's cookies recipe. You learn it once. This is your function. You know, if I give you the ingredients, you can do the cookies. But you learn it just once. Then you're going to do it on a Sunday, on a different Saturday, on my birthday. You're going to make it 3 times. You're going to apply that knowledge 3 times. It's the same thing. You're going to invoke the function 3 times. All right. Moving forward. I think we don't have any more questions. I'm going to remove these because it can make the code break. And I'm going to move forward here. I have another question. Is invoking a function the same as declaring the function? No, Nick. They're actually what I was just saying. Invoking is using the function, is this. It's, again, you learn a recipe just once. You acquire the knowledge. I tell you how to do a given recipe. You have just acquired the knowledge. That is the same thing as declaring the function. You know, the definition of the function is this part. And then I'm going to invoke that knowledge from you. I'm invoking you to prepare that recipe for me. That's going to be invoking the function, making it work. The function's just defined out there in the void, doesn't make any change. I mean, if you know a recipe, you know it. That's it. But it's never applied. There is no difference in the world whatsoever. If now I make you make the recipe, you know, cook it, then you're going to apply the knowledge, and that's when you invoke it. So declaring a function is just declaring it. Completely void, out there, just nothing. All right, moving forward. We had our functions. We saw how the functions work. And this is again the code. We are invoking the function, passing a value, and we're storing that value in a variable. We're going to show that later in a second. So a function will always return a value. A function will always return a value. The way it works, the way the return statement works, and again, I want you guys to see it like syntactically how it's written. You guys have the function definition, and at some point you say return this. This is the result of your function. It's like you can have many lines here computing something. Again, computing revenue, right? You get the sales from the entire year. You have a complicated algorithm, subtracting taxes, subtracting expenses, adding grants. You know, you have such a complicated process to compute the revenue for the entire year. But at the end of the function, at some point, you're going to say, this is the revenue. Here you go. This is the revenue. You're summing everything. You're coming to a final result. It doesn't matter how complex the process was. You were going through all these things, and at some point you said, this is revenue right here, and you hand me a number. You know, you're returning something. Your function has just one result that can summarize the entire function, and a function has a result, and that's what we are returning. And again, returning is just using the return statement. So here, how the return works is, again, it's important to see or to keep in mind this difference between the person or the actor defining the function, the one above this line, this person, and the one using it. Even though we may be the same, like I can be the one declaring my own function and then using it later, might be the same, but it's important to keep in mind this difference. So being these little tiny gracious Santa Claus we have here is it's invoking the function. You know, so the function is already declared. First thing, in this slide, for this slide, this function is already declared. Someone did this. And then Sana comes here and says, I need to invoke this function. I need to calculate the revenue of the entire year. You know, I have given away so many gifts. I don't know if maybe I can go bankrupt, so I need to know how much money I've made this entire year. And Santa invokes this function, passing all the sales, passing all the expenses, all the costs, all to the function, you know, saying like, hey, you take care of these, and it's passing all the data. The function is going to perform some operation, some function, right? Some functionality, some algorithm. It's applying this recipe, this work, and it will come up with just one value for Santa. It's going to say, hey, here's your revenue. You know, it's like, it can take 2 days to compute, but at some point, the function will return one value. And that one value will be the one used by Santa. Make sense? You guys follow it? So let's see, with the same 2Celsius function applied, how these return thing works. Again, from this separate perspective, it's like here along these axes, right here, I can split it into the library writer, the one that wrote the function. This guy is the one that wrote the function, this function. And the one using it, here is Santa. You know, here is Santa. It's the one that it's using the function. So two different actors coming together at the same point. So we have first this 2Celsius function defined. I need your attention here because I know someone's going to ask this in 5 minutes from now. I'm doing this just to keep a reference of the variable. You guys don't need to declare your variables in none, right? I'm just doing it so we can follow the algorithm step by step, but it's not necessary. So how this code works. Let me remove these lines. There you go. The way this code is going to work is, and I want you guys to have a temporal mindset here. It's like we're going through time, you know, where time is passing, and we're seeing these changes or this change in the state of our code. So the first thing that happens is that there is a variable defined, temp Celsius equals none. Like moment 1 of this script, we have a variable temp Celsius equals to none. Moment 2, we invoke the function 2Celsius, passing the value 61, and we mark that we want to store the result of that function in the variable here, temp Celsius. So it's the same variable, right? So what we're going to do now is we're going to jump straight up to the function 2Celsius to now perform that operation that the user wants to do. Again, the user is asking you to please compute the value in Celsius of the Fahrenheit temperature 61. So the function is going to be applied, and it's going to receive the value 61, and it's going to finally return the value. When the value returns, so we started again, moment 0, 1, 2, right? 3, the value is returned. We go back again to where we were before because the function finished. And in this moment, the variable temp Celsius now holds or is storing the result of the 2Celsius function. So there is like this interwork between the function and the end user. You know, it's like I am making something, I am the one doing some work, and at some moment I stop and I give it to you and I say, hey, you take care of this, and I will wait here for your result. It's like I'm working on my desk and I ask you, can you go get me a glass of water? You know, that's your function. Give me a glass of water. So now the execution goes to your side, You will be the one walking, getting the water and bringing it back to me. And the result of that will be you giving to me that glass of water. Make sense? Questions? All right, so what we also had to answer is I remember someone, I think Shoy asked this, how, for example, the value 75 is going to be passed to the function. Again, we're defining the function in a generic way. The function 2 Celsius is going to, it's expecting to receive a temperature Fahrenheit. But at the moment we're writing the function, this is our moment, we don't know how it's going to be used. We don't know it. And as we're defining the function that calculates revenue, we don't know what are the sales yet, but we're going to make it generic. Add all the sales, subtract the costs, a couple of things, and then you have it. That's generic. If I ask you how to compute revenue, you can answer how do you compute revenue, not with a real number. Because if I tell you how do you compute revenue, you're going to tell me you get sales, you add up all the sales, you subtract costs, you add grants, blah 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 blah, and then you have your results. If I tell you, well, give me a real number, you're going to say give me real sales. So if you don't have real data, you have to express it generically. If in this case, as I don't have a real temperature, I tell you how do you compute from a temperature in Fahrenheit, how do you compute it in Celsius? You're going to say you get the temperature in Fahrenheit, you subtract 32, and then you multiply it by 5 and divide it by 9. And I tell you, but give me a real number, and you're going to say, you give me a real value. I can't give you a real number if you don't give me a real value. So as we don't have any real values here yet, because we're defining the function generically, we have to express it generically. So we're going to say, we're going to receive a temperature in Fahrenheit, and we're going to perform this operation, and this entire thing is going to be returned back. I can actually divide these lines, like temperature in Celsius, and then I can return this temperature in Celsius. This thing that I'm doing, splitting it in 2 lines, is exactly the same thing as before. Exactly the same thing as before. I'm just splitting it in 2 different lines, so it's hopefully better understood. So now we have the generic way of expressing a function. Generic. This is generic. What we're gonna do now is see how that matches a couple of real invocations of functions. So now you have it generic, and I'm gonna say, great, now calculate it for 75, and calculate it for 61, and calculate it for 59. What is going to happen is that every time that you invoke the function, for example, with 75, you're gonna apply the same pattern, the same operation, replacing what was generic before, 10 Fahrenheit, with the real value you received. So now I am computing it with the real value 75. And then you're going to do the same thing for 61, and you're going to return the value. You're returning the value back to the user that invoked your function. Make sense? Questions? So a function will always return a value. If you guys don't do it explicitly, right? If we don't put these, we forget. You remember I told you this in our previous class, you will be printing a lot. That's fine. I mean, it's the way to start. But if you forget the return and you still want to, let's say that I forget the return and I do print to Celsius here of 75, what we see is that the function returns none. A function will always return a value. We can explicitly return something, like return temp Celsius. We're explicit about it. We're saying return this thing, and that's of course the actual result that we want. Or if we don't explicitly return it, the function will implicitly return none. Make sense? Questions? You guys doing all right? All right, so we're gonna do now our second part here of this class, that it's dealing with control flow. But actually, we're gonna go really quickly over some meta announcement to do, and then I want to give you guys a break. I want to give you 5 minutes or 4 minutes before we get into that, so I can, like, you can cool off your brains, get some water, go to the toilet, or whatever you guys need. But it's really important. We have a couple of assignments here, both for week 1 and week 2. We're still completing the ones on week 2. We have all the functions, but we don't have the loops yet. I will be updating it, but it's really important for you guys to start working on it. And we will be adding some mentoring support that is going to be available soon during the weekend. You're going to get more information on that later. But anyway, take 5 minutes off. I will ping you all through Slack, and I will start here. Again, it's just 5 minutes. So it's going to be 10:03 for me. It's going to be, what, 7:03 for you in the Pacific. And we're going to keep working on this. All right, so take 5 minutes off. I will ping you all through Slack, and here we're going to start again. All right, so we should move forward. Hope you are everyone back. There was a good analogy here in the chat. Funny XZ. It says, sometimes I like to think of functions as mini programs within the main program. It's actually a really good definition. Yes, it's a really good definition. It's like a small, it's actually, let me think for a second, back in the day, yeah, the name given to functions was subroutine. And it was a routine inside the bigger routine that was a program. It's like a subprogram, smaller program embedded in the main program. So Alex is asking, are there some online calculators or anything that throw randomized simple code problems at you for you to solve solely for your knowledge? How do you mean? What do you mean, Alex? Like give you results and you come up with a function somehow? I don't get it. So Ken, sorry if I don't pronounce it correctly. We had two examples. Yes, let me start sharing my screen again so I can go back to that. And here. And yeah, we can, I'm gonna put side by side the same function, all right? It's gonna be the same function, but expressed in two different ways. I wanna stress the fact that these two things are gonna be the same. This is exactly like this. It's exactly the same as these. All right, the only thing, I mean, this function is computing the, it's computing the Fahrenheit, the Celsius temperature from a Fahrenheit temperature here and here. This is the actual operation. And then we see return that thing. In this one below, this one, the return is directly. We say return this computed value. In this one, the return is indirect, if you want. We are returning temp Celsius, but itself, temp Celsius comes from here, right? And temp Celsius was pointing at this value. So it's the same thing. It's like indirect. It's like I'm telling you, give me the water. That would be this one directly. I'm saying, give me the water. Or I am telling you, give me the, and I'm handing you a paper that has written in it water. So you get the paper from me that itself says water. You know, you're indirectly reaching the same object, you know, the same result, but you're doing indirectly. It's, in this case, it's the same thing to express it in any of these ways. I split it in two lines, this example, because I thought it was maybe more clear to see it, you know, expressed first in this way and then returning the value. So we have a couple of other more questions, and it says, yeah, Alex, so everything you guys have here in the Learn platform, all these are assignments for you to work on. By the way, we're adding more of these every day. So yeah, have plenty to have fun here. And by the way, you guys can always like improve it, you know, or suggest new ones. All right, let's move forward. Jason, there is a special question Q&A section. Jason Brooks is asking where the questions are. There is a special Q&A. Yeah, there you go. Team is answering. Thank you, team. Yeah, I try to like set them again for the recording. So if I forget, please let me know. All right, second topic of today, control flow structures, really important. There you go, control flow. We are going to see, we already saw the idea of the if statement, right? You guys are already confident and familiar with the if statement. And importantly, if you guys did all the practice we had, you know, where you're more than comfortable with the if statement. What we want to do now is see how to repeat code. I'm going to start first with an example, a really simple slash, if you allow me, stupid example. But I want to simplify it to make the code concise. Of course, you guys need to understand that we want to transfer these concepts to more advanced things later. But let's start with something super simple. I want to do something like print the number, print number 1, number 2, and number 3. These are tasks. Printing number 1, number 2, number 3. We then realize that we can, instead of changing these all the time, what happens if I want to add more numbers? I have to go 4, 5, 6, you know. So instead of changing it, what I could do is I can define a variable number. I'm going to say it. Can start with 0 or with 1, let's say. And I can do number, and I can do format number. And then I'm going to start with 0. And then what I'm going to, no, 1, sorry. Going back and forth here. What I'm going to do is I'm going to print the number, but before printing the second one, I can increment it by ones. So I can do number plus equals 1. And I can do the same thing here. So I start with the number 1, I print the number, start with increment by 1 the number. So I have number 2, increment the number by 1 again, I have number 3. It's the same task. On top of that, if I start with 0, I start with 0, but before printing anything, I do this thing again. It's the same result. I see number 1, 2, and 3. But now these things look extremely similar, right? Like they are actually the same code. And what did we say? We don't like to repeat code, so we want some sort of construction or something that we need. Miguel, yes, the class is available recorded for later. So we want some sort of construct, functionality, anything that let us avoid repeating the code. And that is exactly why we're going to use a while loop. We want to repeat a block of code a few times. A while loop, let me get started. You guys can follow with more detail the slides later. A while loop is going to be defined this way. While a given condition, do something. So while this given condition is true, do something. While, how to put it? While you're asking for your user for a password, you know, or for a username, you're gonna say like, and I'm here. I don't want you guys to think extremely about code. Think about a real life example. You're asking for your user for a name, for a username, you know, and your user is giving you a username, and you check if that username is not already taken. If it's already taken, you're gonna go back and say, that's already taken, please select a new one. And that is a repetitive process. While the username that your user is selecting is repeated, you're gonna ask for a new one. No? So give me your username. You get it, you check, it's repeated. You go back again, that's repeated. Give me a new one. You go back, check, it's repeated. You go back again to your user, that's repeated. Get a new one. That third one is not repeated, then you keep it. You know, so you're repeating a certain task while a given condition is true. While the username is repeated, keep doing it. Other example, you're asking your user for a password, and your user is giving you it first. and the condition is going to do something like while password is not valid. I'm writing it in English. This is not valid Python syntax. While the password is not valid, keep asking for a password. So the user is giving you a password. It gives you a password just 3 characters. Is valid? No. Has to have, let's put the rules here. A valid password. Password needs to have more than 6 characters, needs 1 symbol, and at least 1 number, and at least 1 capital letter, 1 symbol here. So these are our rules for a valid password. So your user is going to give you the password. You're going to check if it's valid. If it's not valid, you're going to go back again and say, give me a valid password. The user is going to provide a password. You go check it again. Repeating the same thing over and over and over while the password is still not valid. Make sense? You guys follow it? Questions? All right. So now, how we're going to turn these, what we were just talking, into Python code. This is the form of a while loop. It's while a given condition, and we're going to put here the block of code to execute while this condition is not met, right? So we're going to repeat this block of code, this entire block of code. We can have many lines here. This entire block of code while this condition is met. In this case, I could rephrase the thing, and I'm going to say, while a certain condition, print number and the number. And what is the condition? The condition is simple. While number is less or equals than 3, keep printing it. So let me remove this code, and we're going to check it. There you go. Oh, by the way, less than 3. We're going to print it. So do you guys see it? Anyone has a question? So what we had before was just a block of code repeated. We were doing these 3 times. It's exactly the same code. And then what we did was put it in a loop construct, in this case the while statement, and repeat this code, the same code, 3 times. So if Python was completely awesome, maybe it has something like repeat 3 times and the block of code that you want to repeat. This doesn't exist in Python, sadly. So we need some more work to make it happen. But basically, it's repeat 3 times this number of code. We don't have these, but we have a more generic way. Repeat while a given condition is met. Repeat this thing. And the condition that I'm putting is, again, while number is less than 3. While number is less than 3, repeat this code and print it. So here, if we start with this, I'm going to remove all these, make it work again. We start with 0. We get into this condition. So here it's going to ask, while 0 is less than 3, do this thing. 0 is less than 3 indeed. So it's going to get inside here. It's going to increment numbering 1. Let's do something a little bit more fancy here. I'm going to put these here. There you go. I'm going to put the value. So we're starting right here, right? And I'm going to put the value of number, the variable number, that it starts with the number 0 here. So what we do is, while number is less than 3, 0 is less than 3, we're going to increment number first. So number now is, sorry, having some issues with the drawing tool. There you go. We're going to increment number. That is increment, scratching this value, and now it's equals to 1. Number is equals to 1. I'm printing that value. So it's going to print number and then value of number. So it's this print right here. It finished. This block finished. So it's going to go back again to the top. And it's going to ask again. And now number is no 0, but it's 1. Now it's 1. It's going to say number is less than 3. In other words, is 1 less than 3? Yes, of course it's less than 3. So it's going to go inside here again. And it's going to do number plus equals 1. So here what we had 1, it's going to scratch it again. And now we have 2. Right? So number is no longer 1. Scratch it. And now it's 2. It's going to print it. So now it's the second line, what prints, number 2. And it's going to go back again to the top. And when it goes to the top, now it asks again, is 2 less than 3? Is number less than 3? Number is equal to 2? Yes, of course. So now increments its 1 again, and this is the part we're going to break out of the loop. We're going to increment the number once again. So we scratch this value. It's no longer 2. Now it's 3. It's no longer 2. Now it's 3. I'm keeping 2 in 2 places value of number. It's going to print this line right here. And it's going to go back once again to the top. And when it goes to the top, it's going to ask, is number less than 3? And number is 3. Is 3 less than 3? No, it's the same. It's equals. So number is not less than 3. This condition suddenly is false. Sorry, it's no longer true. It's false. So now it's going to just break out and keep the code working. Make sense? You guys follow it? I'm gonna clear it because it's kind of a mess, but that is. So Ty is asking you a really good question, Ty, here. Sometimes these things, forget about these things. Really quickly, why we have number plus equals 1 instead of number equals 1. I'm gonna go to this one actually. So I have a variable number 0. I'm gonna print number. It's of course 0. What I want to do is increment this value. What I can do is number is now equals to number plus 1. So now I print again number, and I have 1. And I do the same thing over and over again. I do the same thing. I increment number by 1 and I print it. Increment number by 1 and print it. And again, number, the new value of number is equals to the previous one, 0, in this case, plus 1. Plus 1. Now number is equals to 1. So we do the new number is equals to the previous one, 1, plus 1. So we have now 2. And this one is number, the new value of number, is equals to the previous value of number, 2, plus 1, which is, of course, 3. So instead of repeating this code over and over again, Python has a little tiny, I don't know, feature that lets you just write plus equals 1. And plus equals 1, the only thing that it does is the same thing as you guys were saying before. It's just doing whatever you have equals whatever you have plus 1. It's just incrementing this thing by these many units. You, of course, can increment it by 2, by 3, by 5, by whatever number you want. Make sense? You're welcome. Jerome is asking what happens if you don't define the value. You can actually try it. If you don't define it and you try to increment it, number equals number, let's put it in the explicit way. Remember, it's the same thing as doing number plus equals 1. It's the same thing, but let's put it in the explicit way. So Jerome, if you don't define it whatsoever, just leave it as like completely empty, you don't define it, this is going to be an error because number is not defined, because you're asking to define number as the previous value's number plus 1. And what is the previous value of number? Doesn't exist, so it fails. If you do declare it, but that value is none, you're also going to have an error. But in this case, because you can't do the operation none plus 1, it's like adding apples to oranges. You can do 0 plus 1 because 0 is a number and 1 is a number. You can do, I don't know, 5 plus 1, but you can't do none plus 1. You can't, for example, do hello plus 1. It doesn't work either because, again, apples to oranges, you can sum a string to an integer or a number. All right, so it makes sense. You guys are following questions? Good, great. So the idea of the while loop is, again, to give you, well, I could go back again to our previous slides. To allow you to repeat code while a certain condition is met. Do something. While this thing still happens, do this. While the user is still giving you invalid usernames, keep asking for a new one. While there is fuel in the tank, keep driving. While you have ammo, keep shooting. While something happens, keep doing it. You know, so while this condition is still true, keep doing this thing, whatever it is. That's the general form of the while loop. Let me see. Here we had an algorithm. Actually, I just realized this. I'm going to include these slides later. And what we have here is, remember the program from our first class? It was, we had a target number to guess, number 8, for example, in this case, we're of course blowing it away. It's like not really hidden, but we had to guess a number. So if we did something like, I don't know, 5, it's gonna say we lost. But if we guess it, 8, we're gonna say it wins. So we can turn this thing into a repetition code. No. So other good question, there is a do while loop in Python, like in C++? No, it's just while. It's similar, but no, we don't have the do while. So again, this code, what happens, let's say that we want to give our user 3 chances, right? So the user is gonna be prompt with the idea of guessing the number. We're gonna fail, and instead of saying you lose, we're gonna say do it again. You have 2 more tries. Do it again. You have 1 more try. Do it again. You have you're done. Actually, a 3rd time. So Chad is asking, Chad, by the way, if you guys use the Q&A, it's better for me. If you have the plus operator like in C++, I don't know if C has a C++ operator. No, you don't have a plus operator in Python. You have to do plus equals 1. Something plus equals 1. All right, so again, we want to give our user 3 chances instead of just saying you lost in the first one. So we're going to do it 3 times. What we're going to do is ask it the first time. Ask the user for the number, turn it into an integer, and if the guess is correct, we're going to just say you win. Else, we're going to, if the user doesn't guess it correctly, what we're going to do is we're going to do, actually here I should exit, like stop the program. Just going to put this here. We're going to change it later. So just for now, it's not. No, actually, we should combine these with a function. Let's wrap it up. I have already presented all the topics from the class, functions and while loops. So what I'm gonna do here is we're gonna check this problem. We're gonna turn it into a function and make it repeated. So the first thing that I want to do is I'm gonna define a function. It's gonna be def play guess number. As someone gave a definition today, play guess number, it's sort of like a mini program inside our bigger program. And this is going to be our function. Now, this is the code for our function. From outside the function, when I want to kick it off, I want to get the function started, I'm going to do play guess the number. And here I'm going to receive a parameter. What does the play guess number return? You know, let's define it. We are the ones defining this. So play guess number is going to return if the user won or not. So it's going to return either true or false, given the condition that the user won or not. If the user guessed correctly, we're going to return true. If the user fails with the 3 intents we're giving, the 3 trials, 3 opportunities we're giving, then we're going to return false. So here it's going to say user won, and print if the user won or not. Play guess number for now doesn't receive any parameter. We're just gonna make the program start with this function. So we don't pass any parameters, but we do receive something as return. So now let's get started here. I'm gonna say target number equals 8. This is the number that the user needs to guess. And we're gonna ask the user for a number. The user will guess a number, and we are going to turn it into an integer. This is again what we were doing in our previous class. If the user guesses the number, we're going to say you win, and we're going to return true. The user guessed. So if this thing happens, let me run it. Actually, let me stop it. I'm going to put something different here. Print hello world. And print you won't see me. I'm gonna print this. If I guess correctly, I see you win, and return true. Return will completely finish and terminate a function, right? Completely finishes and terminates a function. Return means this function is done, and it's returning this value, right? So it's did we have it? Somewhere along these lines. When a function returns, it's done. It doesn't matter if the return statement is on the first line of the function, in the middle of the function, or at the end of the function. The first return that it's reached completely terminates the function. So that's why you guys don't see these, and that's expected. So if the user guesses the number correctly, we are going to print you win and just return true. And the function is done, finished right there. In other case, we're going to say the user, for example, incorrect, guess again, and guess again, and now we're going to do guess in this thing. It's going to turn it again. If guess number, now again. So now we're going to have 2 tries. If I miss the first one, incorrect, guess again, I nail it now and says you win. That's fine. And we're going to do it once again. User's answer. We're going to copy and paste the same code. There you go. And if the user wins, we're going to return you win. If this doesn't happen, we're not going to give it a third time. Now here, what we're going to do is print you lose, return false. The user didn't win. So let's run the whole thing again. Again, I'm going to make it fail the first time, make it fail the second one, make it pass on the third one. it says you win. It was right there. This was the one executed. If I run it again, but now I make it fail 3 times, 1, 1, 1, it's going to say you lose, and it's going to return false. So how does it work? Again, once, twice, 3 times. If the user didn't finish here, we're going to reach this code, print you lose, and return. Make sense? You guys follow it? The return doesn't need to limit or encapsulate it or anything, and doesn't need to be a Boolean. I can return yes. The user won, yes, yes, yes. User won, no. So user won. Let's win in the first time. User won, yes. Oh, I need a space here. User won, user gets the number. There you go. User won, yes. Let's do it 3 times. Bad. 1, 1, 1. User won, no. So we don't need to put the return doesn't need to always return a Boolean. Can return whatever you guys want to return, and you don't have to enclose it. You don't have to do anything. You just put return and whatever you want to return. So is there a limit? No, there's no limit. And yeah, Kenneth, you can do that. That makes a lot of sense. Instead of printing inside a function, returning it, that might be better. I'm just keeping the code as it was, but yeah, usually we will try not to print inside the function. Just for now, we're gonna leave it as it is. All right, so again, we're seeing here 3 pieces of code that are extremely Jessica, we're gonna actually do that example in a second. What if we have 2 potential target numbers? That is a completely different algorithm, of course. It's a completely different business logic. You know, it's like instead of having just 1 product at discount, we have 2 products at discount. It's a completely different business logic, but it's easy to resolve in any way, and we're gonna do it in a second. So we can kind of in how much we've been here for 1 hour and 25 minutes, and you guys are already getting this notion of functions. I'm extremely happy. We're turning what was our simple algorithm from the first class now into a function. That's awesome. What we're gonna do now is remove this duplicated code and turn it into a while loop. All right. Whenever we are repeating, we want to turn this thing into a while loop. So what we're going to do now is we're going to do while a certain condition is met, do this thing 3 times, 4 times, whatever times we want to do it. Do this thing while a given condition is not met. So what we're going to do is I'm going to remove all these things for a second. I'm going to also remove these. We will have to take care of these. It's not going to be covered probably in the while, but just to again show you how we process this. So while a given condition, ask the user for a number, turn it into an integer. If the guess is correct, print you win and return yes. Now, what is the condition? This is what we have to think carefully, and this is one of the most important things for a while loop. What's the condition that it's going to make this code pass? Or sorry, will make this code keep repeating, or will make will break the loop? You know, will stop repeating. This condition is really important because if you guys fail with this condition, if you somehow end up with something that is always true, you're stuck in an infinite loop, and an infinite loop is really bad. The code is the computer literally stops responding to you. I can try an infinite loop here so you guys can see it. While true, print hello. It's gonna be really ugly, I guarantee you. There you go. It's not responding. You know, it's like, there you go. I had to stop it. So a while true and infinite loop is really bad. So if you guys, for example, are doing number equals 0, and then you do number, remember our previous example, number, sorry, we're doing this, but format number, and we forget, and we're saying number, well, number is less than 3, but we forget to increment number. Number is always 0 for the eternity of this program is 0 because we're never incrementing it. Then we're stuck in an infinite loop, and again, this is bad. This is ugly. So see, I can't even stop it. Super bad. Can I stop it? No, it's completely broken. So again, a while true and infinite loop is something we don't want to get into. So again, while condition. We have to find a condition for this thing. We have to be really careful about the condition. And we can think about different things here. And usually when you guys are writing and thinking about your conditions, you have to just give it like, you have all your the Python language for you guys to use and put into practice. So you can use whatever thing you need here. Do it at your extent, you know? Just satisfy whatever you need with the condition. What I'm going to do here is I can make it up. There are different ways to fixing this. I can do something like while number of times guessed. I'm going to put here a number 1 here. I'm going to say while the number of time guessed is less or equals than 3, ask a user for a number, turn it into an integer as we knew. If the guess number is equals to the target number, print you win, return yes, that's as we knew it. But if this is not the case, increment it. So number of time guessed, now we're going to increment it by 1. So now we have that our condition is the number of time guessed. We're going to keep repeating. We're going to keep giving our users more chances as long as the number of times that the user had tried to guess is less or equals than 3. If the user guessed incorrectly, we're going to increment this variable by 1. So let's actually run this thing. Guess the number 2, guess the number 1, guess the number 2 again. There you go, finished. By the way, we're getting this error because we're not returning anything. So let me just put the user 1 thing again. So it's 1, 1, 1, print none. What happened here? Why are we seeing this user none, this print none here? Because this program finished. It's like we did this thing, 1 second, this thing over and over and over again 3 times until it's just exit and moved right here. And we didn't return anything. And remember, if we don't return anything explicitly, the code will return something for you, and that something is none. And it doesn't matter that we had a return here. We never reached this line. This code was never reached because the user never guessed the number, right? So the code ended up right here. So what I'm going to do now is I'm going to put what I had before, print you lose, and I'm going to return no again. Where we can put no again and go back to our user 1. Guess the number 1, 2, 3, you lose. You see, this line is invoked. Return none. No is what we see right here. So we have a couple of questions. 1 second. Tim asked, the return yes takes you out of the while loop too, right? Yes. Yes, and Tim, this is a really important thing. Thank you for asking. This is really important. A return statement will get you out of the entire function. It doesn't matter how many levels of nesting you were currently in, it doesn't matter. It doesn't matter if you were, I don't know, if you were inside a while loop, inside an if statement, inside a while loop again, inside another while loop. Whenever you put return, it completely returns back to whoever was invoking it. So it's coming back here. So if we could measure this like in levels of nesting, we're in level 0 here. We invoke the function, so we get back to this place. And here, from here, we get back to this place. And from here, we get back to this place. And when we reach this line, all this goes back to here, and user1 is equals to yes. A return completely takes you out of wherever you are. And funny xz, sorry, the name is like maybe your username or something, is the function or the while loop. Is the function or the while loop the one that generated the none? The function. The function. If we don't return, remember, if we don't return, let's say this once again. I'm answering by the way. If we don't return, let me run it. We're going to do 1, 2, and 3. Oh, sorry. Once again, 1, 2, and 3. You lose none. So why do we see a none here? Again, we kick off this game. Starts here. Number of times guessed is equals to 1. It gets here. Number of times guessed less or equals than 3. Sorry, 1 second. Give me 1 second. There we go. So numbers of time guessed is less or equals than 3. What is numbers of time guessed? 1. Is 1 less or equals than 3? Yes, it is. So we get inside this while loop and we start repeating. We execute this entire block. We ask the user for a number and we check. The user here gave us the number 1. This one right here. Is 1 equals to 8 target number? No, it's not. So we never get inside here. It's like this thing doesn't even exist to us. We never get inside here. We get here, we increment by 1 number of time guessed. So now these turns to be 2. So we go back again to numbers of time guessed. Sorry, we increment this value and we go back again to the top of the loop. We execute it again. And now we do number of time guessed, that it's 2. Is 2 less or equals than 3? Yes, 2 is less than 3, so this is true. It's gonna get inside here, ask for another number, and gonna check it. What number did we provide? We provided number 2. So is 2 equals to 8? No. Again, this code doesn't exist. As this condition is false, we never get inside here. We just skip it completely. We go back again here, and we increment number of time guessed. So now this thing is 3. Numbers of time guessed, which again is 3, is less or equals than 3? Yes, is equals. So we go back again to the for loop. Sorry, the while loop, inside the while loop. We ask for another guess, and we check it. We provided the number 3 here. Is 3 equals to 8? No, still failing. So we never get inside here. We don't. We increment this thing once again. So this now is 4. This value is now 4. We go back again here, and here we're gonna ask, is numbers of time guessed less or equals than 3? Is 4 less or equals than 3? No, 4 is greater than 3. So we should skip this thing, we never return, and we go back here. And this line is executed. And as we are not returning anything explicitly, we don't return anything explicitly. None is returned for us. Python is returning none for us. And that's how this thing works. Sorry for the scratching. In an else block, yes, Yeah, good comment by Shafi here. It's actually a question, but it's actually a good comment too. This is a kind of a binary condition, right? Will happen this thing or something completely different. And actually, I think that this could be a little bit more correct here. Like if the guy guessed correctly, print you win, or return yes. Else, in other case, their user didn't guess correctly, increment the variable keeping track of that by 1. But as we are completely returning from this, if we ever experience this scenario, if we ever experience this case, we're going to completely return, so we don't need it. We can just leave it out. Because if there are two possibilities, the user will either guess it. If the user guesses it, we're going to print it and return completely. The function stop, we return. That's one possibility. The other possibility is that the user doesn't guess it, of course. And here we will not get inside here. We'll just pass directly. We will like bypass it directly to this line, and we're going to increment it. So in this case, putting an else or not putting an else is the same because of the return. The return is the one, the really important one here. It's okay if we just use break instead of returning it, then just call the function at the end. You can break, it doesn't have anything to do with where you put the function. If you break, you have to do something differently. I don't like to talk about break right now. You guys will see it in the slides. Because break, it's actually like a hack, to be honest, at this point. You should master this way. There is nothing that you can do with break that you can't do with the traditional. I'm being old school here. I want you guys to write the things as they are properly written with the condition and manage your conditions properly. And then you can see the hacks, but please try to make it work with the conditions first. So to avoid mistakes. It's like the break is just a hack that sometimes serves as a shortcut, but there is nothing that you guys can do with the break that you can't do with a traditional condition. All right, so finally, we're gonna return here the no, so we can show that in our user. We're gonna guess with a 7, with a 9, with a 4, 5, and we say you lose no. Or we're gonna now guess it correctly. I'm gonna guess 3, it's bad. I'm gonna guess 8, and there you go. It just works as expected. Now, something else that I could do is I could pass, so before I said play guess number, it's just play guess number. But this function is not really flexible because it will always guess the number 8 and it will always give the user 3 chances. I want those that have ever played a game, a computer game before, a video game before, to think about when you go to the settings of your gaming, and you just customize your game. What you guys are doing is exactly this. There you go. So you're making your game extensible, flexible. You're allowing your user to customize it in this way. You're defining a game that it's kind of generic. It will change, it will morph depending on in the way you want to invoke it. It's not a game, it's not the same thing a game played in easy level that played in normal or super hard mode. Now all these modes will give you a different experience. And here's going to happen the same thing. We're going to use the play guess number function. In this case, we give the user 3 chances. So here can use 3 chances. Or we can make it a little bit harder. Let's just give the user 2 chances. We're gonna do 2, 1, and you're done. You lost. Or just give it 1. Like super complicated. super extra god mode. 7. No, you're done. So we're making the game extensible by providing parameters to the function. And again, we're defining the game, we're defining the function, we're declaring, defining, writing the code for a function in a generic way. While the number of time guessed is less than chances. What is chances? I don't know. When someone wants to play this game, that someone needs to provide a number of chances, and I will know it at that time. What's the target number? I don't know. What I care is that the user will try to guess a number, and I will check if it's the same one as the target number that the original user wanted. If that's the case, that's it. Yes, Ty, so we can. It's not that hard. I'm gonna show it to you guys because I think you're in the ready to start playing, working with these things. Import random. You guys know about this comic? I guess you all know these guys, right? XKZD. There is this comic, Import Anti-Gravity, that it's just like the guy is flowing just by doing import anti-gravity. This means that Python has so many cool libraries out there, so generating a random number is super simple in Python. We're gonna do random, and here we're gonna give it, let me open the REPL so I can show it to you separately, and then we're gonna integrate it with this script. So we're gonna do import random. This is what you want, and the one that generates the random is from random.randint. Randint is the function. This is a function, by the way. This is a function. We're using an external function. From random, import randint. Sorry, import random, and we're using from random the function randint, and we're passing parameters, as you guys know it. We're gonna pass from 0 to 15. So it's gonna give you a random integer int in the range of 0 to 15. And here we're gonna print this value, 6. We're gonna print several values, and these are all random numbers. See? So we can use that in our code. We're gonna play guess number. We're gonna put here target number equals dot target number. So we don't know it yet. So I can let's diminish the difficulty of this. I don't know. So now we don't know it. We completely don't know it. Like I don't know. I'm gonna put 4. No. 2. No. 9. No. I lost. By the way, those of you that let's put cheating here. Like let's cheat. Let's create a cheat in our game. We're gonna put print debugging mode. The target number is, we're gonna pass here format target number. There you go. So now we know it's 5. So we're cheating, but it lets us win the game. So now the number 13, 2, 13. There you go. We win. All right. No, I can't. So questions, how do you guys feel it? We've seen so many things, interesting things today. The lesson, you guys can access it right here. Once again, let me wrap it up with these functions, enter the functions and loops. You guys go to rmotr.com/students. You're gonna be dropped in this page. This is our second unit, second week, second class, enter the functions and loops. Today, July 28th. And here you will see a little like this one, like this icon is actually let you watch our previous lesson. So one of these is gonna appear right here. And we're adding more assignments here. If you guys don't practice, there is no point of watching me talk nonsense. So please go and practice. Practice as much as you can. As I told you, we will be adding optional mentoring support. We've been asked to add like help. Of course, it's optional for you guys that are working and having issues. But again, try to practice as much as you can. All these, it's like, I guess that you completely understood what I told you. Like when I was explaining it, it makes sense, but when you guys have to do it by yourselves, it's gonna be hard. Adrian panelists are just people sitting there that are able to talk or ask questions or share their screen or whatever. Chad, there is a for loop. A for loop is actually preferred over a while loop. Sorry to say right this, saying this. No, intro to collections is actually next class, August the 4th. Chad, there is a for loop and we use it all the time. We actually prefer it over the while loop, but the while loop is like the more primitive one. It's the one that we need to understand first. And to be honest, I need you guys to burn with a while through loop. You know, I need you to do these and experience the pain of these, and then you are going to understand why it's so cool to have for loop. So yeah, we have for loop and works completely different than other languages, by the way, completely different, but we do have it. All right, so this is it. See you all next Friday. We had half of the people from our previous Friday, so congratulations to you all. I mean, you guys are doing the hard work. We know. I mean, Friday 6 p.m. it's hard, we know it, and you guys are here hustling, so congratulations for being there. You know, you will be the ones making it. You know, it's hard. You guys are taking what it requires. All right, so have a great weekend and see you all on Friday. Do all the assignments, the individual work, do your homework. All right, see you. Bye.